today at the International Astronautical Congress? Just by show of hands, raise your hand if you've been to an IAC before. We got a good number. Raise your hand if you've never been to an IAC before. An even bigger number. Fantastic. Well, this is a big deal for the United States of America to host this conference here. We have the opportunity to showcase what we are doing as an agency. By the way, just so everybody here knows, my name is Jim Bridenstine. I'm the NASA administrator. So I have the honor of leading America's space agency in exploration and discovery and science. And here in Washington, D.C. this week, we have been hosting the International Astronautical Congress, where all of the nations of the world that are interested in space, that want to have space agencies, that have space agencies, we convene and we talk about what we're all going to do together when we explore space. Because here's what we know. Science matters to all of us. And as we make discoveries and we explore, we all want to be able to share that information. We don't want to duplicate efforts. We want to keep going further and go further and faster than ever before. And of course, we can all do that when we work together. And that's what the International Astronautical Congress is all about. And we've been hosting it here in Washington, D.C. this week. Next year, it's going to be, in fact, in Dubai. So we're looking forward to that as well. And I would encourage all of those that are here to consider going to the one in Dubai a year from today. But here's the thing. There's a couple of things that I want to start with that are important. Some major discoveries, and I know this. There's a lot of people in this room that maybe you're not involved in the space industry. This is public day. This is the day when people from the public who might not otherwise be involved in space have the opportunity to come to the IAC and hear what NASA is up to. And I've got about an hour, I'm being told 56 minutes according to the clock here, to give you an update as to what NASA is up to. But to start, I want to share some things I think that are absolutely remarkable. We had 2 rovers on Mars not too long ago. Spirit and Opportunity. Opportunity lasted 15 years. Spirit lasted 10 years. And these little rovers on Mars gave us some significant discoveries. Because of these 2 little rovers, we now know that Mars had an ocean in its northern hemisphere. That ocean constituted 2/3 of the northern hemisphere of Mars. We know that Mars had a thick atmosphere, and Mars had a magnetosphere because of these 2 little rovers. In other words, at one point in the history of Mars, it was habitable. It could have hosted life. Do we know that it did? No, we don't know. But I'll tell you what, we want to go find out. But I want to tell you something else that's important. Within the last year, maybe the last 15 months, some really amazing discoveries that have happened. Number 1, and this is because of Curiosity rover, another rover that is still active on Mars, and the InSight lander. Here's what we know. We know that Mars is covered with complex organic compounds. In other words, the building blocks for life are on Mars. Does that mean life is there? We don't know. But we know that the building blocks for life exist on Mars. We know that they don't exist at all on the moon, but they are in fact all over Mars. The probability of finding life on another world just went up. We also know in the last 15 months that the methane cycles of Mars are commensurate with the seasons of Mars. Does that guarantee life? No, but it is an indicator. It could be geological in nature, but it also could be an indicator of life. The probability of finding life on another world just went up. Finally, here's what else we have discovered, and this is with our international partners. Liquid water on Mars, 12 kilometers under the surface of Mars. What do we know about liquid water on Earth? Wherever it exists, there is life. Is that true on Mars? Again, I don't know, but we need to go find out. This is something that is important to NASA. It's important to the United States of America, and it is in fact important to humanity. There is one person that I know who is more interested in finding life on another world than any person I have ever met in my life. And I had a very distinct honor to serve with this gentleman in the House of Representatives. This is somebody, and I'm going to introduce him here in a few minutes, but I want to tell you what I know about him personally. He was an appropriator. In fact, he chaired what was called the Commerce, Justice, Science Appropriations Committee here in the United States House of Representatives. This was something that was on his heart. It was a desire of his to chair that committee for a reason. He wanted to go find out if there's life on other worlds. And as chairman of that committee, he had oversight of NASA. He was able to make sure NASA had the funding it needed to achieve its objectives. And he was one of those appropriators that made sure, and this isn't normal in Congress, but he told me this. He told it to me over and over again. He said, I will never put a mission on you that I also don't fund. And he works bipartisan, across the aisle, Republican and Democrat alike, to make sure that NASA had the resources it needed to go find life on other worlds. I want to introduce to you somebody who I consider a dear friend, Representative John Culberson. If you'll come up. The Honorable John Culberson. We are honoring Representative John Culberson with what is called NASA's Distinguished Public Service Medal. This is the absolute highest medal that we can give to a citizen of the United States. We are so grateful for all of your leadership and all of your help, and oh, by the way, all of your funding for our missions. So with that, I'd like to give you this medal. This is the Distinguished Public Service Medal from NASA.
Thank you. This singular honor is all the more meaningful to me because it has been presented by, in my opinion, the very best administrator NASA has ever had in my 18 years in Congress. You're the best cheerleader the agency ever had and the most knowledgeable.
Just so you know, there's other NASA administrators.
Thank you, Jim, for this important recognition and for all your help during our time together in Congress to help lift up America's space program in a bipartisan way. We always did so in a bipartisan way. I especially want to thank my wife, Belinda, and our daughter, Caroline, for putting up with all the aggravations and long separations caused by my public service, and for enduring my lifelong obsessive fascination with scientific discovery and space exploration. I also want to thank my new law partner, Kevin Kelly, for helping me better utilize the power of the purse as an appropriator, as a chairman of the Commerce, Justice, Science Subcommittee to enforce the law as the founders intended. The power of the purse is the most important check and balance in the Constitution. And I want to thank Kevin for helping me get started so successfully in this new phase of my life. Above all, I want to thank the voters of West Houston for entrusting me to represent them in the United States Congress for 18 productive years. They supported me in all of my most visible work, expanding Interstate 10 in West Houston and rebuilding after the devastating floods of Hurricane Harvey. But the voters of District 7 also supported me in my less visible work in support of medical and scientific research, and the work that gave me the greatest joy is, of all, to restore our space program and to lift NASA funding as close as I could get it back to the glory days of Apollo. One of my heroes, the great Mars scientist Steve Squires, told me that Carl Sagan often said that exploring the solar system and homesteading other worlds constitutes the beginning much more than the end of history. I am so fortunate to have had the privilege to help make that dream come true for the American space program. With the help of my colleagues and the support of my constituents and my family, in my 4 short years as chairman of the Commerce, Justice, Science Subcommittee, we were able to significantly increase overall NASA funding. We doubled the planetary science account so that we could finally, thank you, finally, that's really important, because by doubling the planetary science account, we can finally have the proper balance and launch cadence of flagship, New Frontier, and Discovery class missions. And they won't have to fight each other so much anymore. And everybody gets a chance, and you can pick the best mission, Mr. Administrator. And best of all, working together in a bipartisan way, we ensured that it will be an American orbiter and lander, as part of an international team, that will be the first in human history to seek out life in the hidden worldwide ocean of Europa. And we laid the groundwork to ensure that it will be an American spacecraft, as part of an international team, that will be the first interstellar mission to travel to the nearest Earth-like planet with a spectral fingerprint of life in its atmosphere. The most exciting and meaningful part of my 18 years in Congress has been my work with all of you in the space program. All of you who can see over the horizon into the far future and help you make those dreams come true. Because I share the same passionate belief of my favorite founding father, Thomas Jefferson, who often said, "I like the dreams of the future far better than the memories of the past." Thank you very much. Thank you, Jim.
Well, thank you, Representative Culberson, for your leadership in the House of Representatives, and of course, you're not done yet.
Not done yet.
He calls me to make sure that I'm following the laws that he wrote when he was in the House, and we're very grateful for that. So keep it up. All right, thank you always. Yeah, keep it up. Okay, so we talked a little bit about what we have found on Mars. Know this, we have done not just all these rovers on Mars, but one thing that I think is important to remember is in November of last year, we landed on the surface of Mars for the 8th time in human history with a lander we call InSight. And when we landed on Mars with InSight, it was on the cover of every newspaper worldwide. And really, for the first time, I saw just how impactful this little agency called NASA, that receives less than 0.5% of America's federal budget, how impactful this can be all around the world to inspire children and really shape the imaginations of children, not just towards exploration, science, and discovery, but also shape it towards the United States of America and how we want to build a coalition of nations. When we landed InSight on Mars, we didn't do it alone. Yes, it was an American spacecraft, but we went with international partners. And when our international partners were with us on the cover of all the newspapers worldwide and talked, there was the last paragraph and all of the articles talked about all of the instruments from our international partners and the technology from our international partners. And that, I think, is inspirational for everybody in the world when we lead these efforts. And we're able to do that because of the support and help of John Culberson and, of course, members of Congress that are in the House today and the Senate. So, but InSight was the beginning of my time as the NASA administrator. Just a few short months after we landed InSight on Mars, which was absolutely spectacular, we had the opportunity to enter orbit around Bennu, an asteroid in deep space. We entered orbit with a little spacecraft we call OSIRIS-REx. OSIRIS-REx is right now in orbit around Bennu, and it is going to go down and grab a piece of Bennu and bring it back to Earth. For the first time, America will do an asteroid return mission. And I think that is going to be a significant achievement. Japan has done one with Hayabusa. Japan is already doing Hayabusa 2. And now we're going to be able to exchange samples internationally, not just exchange samples, but have our scientists and their scientists working side by side to evaluate the samples that come back from these two very important missions, the United States and Japan, each leading their own missions to these asteroids in deep space. That happened, I think it was on December 27th. And then on January 1st, we had a little spacecraft that we call New Horizons. This little spacecraft called New Horizons, which gave us the beautiful images of Pluto in 2015. Raise your hand if you saw those images of Pluto in 2015. They were phenomenal. Thank you for doing that. I just got to know my audience, right? So those beautiful images of Pluto were not the end. They were the beginning. New Horizons kept going, and it went way out to what we call the Kuiper Belt, where there's all kinds of objects in deep space. We're talking about 4 billion miles from Earth, and we got these beautiful images of something called Ultima Thule, an asteroid in deep space that is in fact what we now know to be a binary contact. 2 asteroids that came together, and we are still getting absolutely beautiful images back from the New Horizons spacecraft that gave us the beautiful images and the science and the data on Ultima Thule. Now, while we're on this topic of New Horizons, there's something else that I think is important to note. 2006, many of you in this room are aware that Pluto got downgraded from a planet to a dwarf planet. Boo! I hear some people booing. That's my sense. So that happened before these images we got in 2015 and before the science that we got in 2015. And some people have argued that a planet, in order to be a planet, you have to be able to clear your orbit around the sun. Well, what we now know is that if that's the definition that we're going to use, you could really undercut all the planets. They're all dwarf planets because there isn't a planet that clears its entire orbit around the sun. That being the case, I think it's a sloppy definition. Many of you have heard me say this publicly. I think the way you should define a planet is based on its intrinsic values, not the values that constantly change like orbital dynamics. So when I think about Pluto and what we got back from New Horizons, here's what we know. Pluto has an ocean under its surface. Pluto has complex organic compounds on its surface. Pluto has a multi-layer atmosphere, and Pluto has its own moons. I'm here to tell you, as the NASA administrator, I believe Pluto is a planet. And I'm going to continue to tell everybody that I believe Pluto is a planet. And I know there's a lot of scientists out there that agree with that assessment. And we need to keep letting people know. Because that New Horizons mission was amazing. And it's giving us great information. Okay, so from New Horizons, in February, we saw the Crew Dragon, one of NASA's commercial crew programs, attached to the International Space Station. We are on the cusp of, once again, launching American astronauts on American rockets from American soil for the first time since the retirement of the space shuttles in 2011. And I want to be clear, we need to return to that activity, and we need to go with our international partners. We're looking for all of our international partners to step up and help us as we work to commercialize low Earth orbit. Here's what we're trying to achieve. We are using the International Space Station for really 2 lines of effort for an eventual commercialization of low Earth orbit. These 2 lines of effort include industrialized biomedicine. And here's what we're trying to do. We're looking for breakthroughs. We need breakthroughs that will transform how we live on Earth. And when those breakthroughs occur, capital will flow into what will be commercial habitation capability, commercial space stations in low Earth orbit. So how do we do that? 2 lines of effort. Number 1 is industrialized biomedicine. Right now we are using the International Space Station to compound pharmaceuticals and create immunizations in ways that we cannot do here in the gravity well of Earth. Right now we are using the International Space Station ultimately to print in 3D human tissue and eventually human organs using adult stem cells with the purpose of transforming lives here on Earth. We're using the International Space Station to create artificial retinas in orbit. These are things that you cannot do here on Earth because of the way materials are layered, but you can do it in the microgravity of space. And when it is successful, by the way, imagine this. Imagine a box that fits in the palm of your hand. Up the box goes with materials inside, and when that box comes back to Earth, 1,000 artificial retinas. So people who have macular degeneration don't have to lose their eyesight. I'm not saying it's going to happen. I'm saying we're working on it, day in and day out. We are using the International Space Station to create these breakthroughs that will result in capital formation so that we can have a day of multiple space stations funded by commercial industry so that we can continue to have a presence in low Earth orbit, and NASA, of course, will always have a presence. I want to be clear. NASA will always have a presence. We will always be a customer. But just like what we are doing with commercial resupply to the International Space Station, NASA wants to be a customer. We want to be one customer of many customers in a very robust commercial marketplace in low Earth orbit. And we want to have numerous providers that are competing against each other on cost and innovation. Why? Because that's how we drive down cost. That's how we increase access. And we're doing it right now with commercial resupply to the International Space Station. We eventually want to take that, and we're almost there. We're on the cusp of doing it with commercial crew to the International Space Station, with two separate providers that are competing on cost and innovation. And by the way, there could be others, and we're very anxious about making sure that there's opportunities that go beyond what NASA has already funded. But then eventually what we need to do next is we need to see habitation in low Earth orbit that is commercial in nature. So we need that industrial biomedicine to be successful, and we need advanced materials to be successful as well. We talk about Z-band and fiber optics. These are just some of the capabilities that we are using the International Space Station to prove out that you can create very pristine, clear fiber optics in a way that ultimately, if it's achievable, will reduce the cost of fiber optic networks here on Earth. The business case closes and capital will flow to commercial habitation and, in fact, in-space manufacturing in ways that right now does not exist. We are using the International Space Station for commercialization. I want to be clear. Some people would suggest that the International Space Station competes against private habitation in low Earth orbit. That is fundamentally untrue. We are using the International Space Station to enable our commercial operators to ultimately be successful. So in low Earth orbit, commercial resupply, commercial crew, eventually commercial habitation. Here's what we know. We do not want a gap in low Earth orbit. You know, we had the challenge with Apollo is that it ended. And ultimately, when it ended, we had an 8-year gap before the shuttles. And then we had the shuttles that ended. And now we've had another 8-year gap before commercial crew. We want to make sure that we do not have a gap with presence in low Earth orbit. There are kids graduating from high school today that have lived their entire lives with Americans living and working in space. And by the way, international partners with us living and working in space. That's a fantastic development for our country. It's a fantastic development for the world. We want to make sure that that never breaks. How do we do that? We use the International Space Station to create the commercial habitation requirements. Ultimately, that's how NASA becomes a customer, one customer of many, and we have numerous providers that are competing on cost and innovation. Everything I've just talked about is low Earth orbit. What we need to do after that, when that is successful, all of a sudden the costs for access to low Earth orbit go down, access goes up, and then we can use the resources that the American taxpayers give us to go even further, to do what already we're not able to do, and that is we need to go back to the moon, we need to go sustainably, and that is what Space Policy Directive 1 is all about. When we go to the moon this time, we go forward to the moon. We're not going back to the moon, we're not going to the moon, we're going forward to the moon. In other words, we're going to stay for long periods of time. We're going to go with international partners. We're going to go with commercial partners. We're going to utilize the resources of the moon. And when you think about what those resources are, Hundreds of millions of tons of water ice that we know exist on the south pole of the moon. Probably more. The north pole of the moon, there's water ice as well. How much? We need to find out. We know this. We actually have a mission right now that I'm very pleased to announce. It's called Viper. We're going to take a rover to the moon with a new program we call CLIPS, the Commercial Lunar Payload Services. We're buying services to go to the surface of the moon. We've got a number of companies right now that have IDIQ contracts that we've identified that we believe can take us to the moon, where NASA is not purchasing, owning, and operating the hardware, but instead we're buying a service to get activities to the surface of the moon. The reason, again, being we want those companies to go get customers that are not us, to drive down our cost and increase access. And a lot of these companies are doing just that. But we're going to use CLIPS, the Commercial Lunar Payload Services program. We're going to use that to deliver Viper to the surface of the moon. Viper is going to rove on the south pole of the moon, and Viper is going to assess where the water ice is. We're going to be able to characterize the water ice and ultimately drill and find out just how is the water ice embedded in the regolith on the moon. Why is this important? Because water ice represents something significant. Life support. Water ice is oxygen to breathe. It's water to drink. Hydrogen and oxygen, when you crack it into its parts, hydrogen and oxygen is the same rocket fuel that powered the space shuttles. It's the same rocket fuel that powers the SLS rocket, which will be coming out of the Michoud Assembly Facility here at the end of the year. The most powerful rocket America has ever built. It is going to take our astronauts back to the moon. It's a hydrogen and oxygen rocket. Here's what we know. Oxygen and hydrogen is available on the surface of the moon, and hundreds of millions of tons rocket fuel is available on the surface of the moon. It can be used, and we need to use it, not just for life support, but even for maybe even rocket fuel. So we're going to the moon sustainably. We're going with international partners. We're going with commercial partners. We're going to utilize the resources of the moon to learn how to live and work for long periods of time. And then ultimately we're going to take what we build, what we understand, the technologies, the capabilities, the architecture, and as much as possible, we are building the architecture to be replicable at Mars. We've already talked about why it's so important to go to Mars. Complex organic compounds. We have methane cycles commensurate with seasons. We have liquid water 12 kilometers under the surface of Mars. We need to go find life on another world if it exists. And I know that Chairman Culberson is all about this, and we're working hard to make it happen. And Chairman, you are the legacy. We're going to make sure that this gets done. So as we go forward, there's a lot that needs to be done. In order to create the architecture that we need to create at the moon, we've got to have the SLS rocket. Again, the most powerful rocket the United States of America has ever built. We need a European service module. When we go to the moon for the first time, it will be international in nature. The European service module is a critical component to the Orion crew capsule. The Orion crew capsule is how we get our astronauts to the vicinity of the moon. But there's not enough delta V there to go to low lunar orbit and land on the surface of the moon. So we need to get more delta V. Where do we get that? We are building a reusable command module in orbit around the moon that we call Gateway. Gateway is going to be in orbit around the moon for 15 years. Gateway is important for a number of reasons. We are not rebuilding the International Space Station in orbit around the moon. What we are building is a sustainable command module that will be there for 15 years that is maneuverable. Solar electric propulsion. It can go to the North Pole, it can go to the South Pole. Why is that important? There is a lot about the moon that we don't know. From 1969 up until 2009, we thought the moon was bone dry. Why? Because we landed in the equatorial regions of the moon. And we assessed that the whole moon was like those equatorial regions. 2009, we made these amazing discoveries with our international partners that there's hundreds of millions of tons of water ice, specifically on the South Pole. How did we miss it for 40 years? Well, it's because we didn't go to all of the moon. There is so much more about the moon that we need to learn. So the Gateway is maneuverable. The Gateway is also an enabler for international and commercial partners. When we build the gateway in orbit around the moon, it's going to be open architecture. When I say it's open architecture, what I mean is the way we do docking, the way we do data, the way we do information, the way we do avionics, the way we do environmental control, life support, it's going to be available and published on the internet for everybody to see. And our international partners, whether you're a big country or a small country, maybe you're a private company, you will be able to propose to NASA how you want to utilize the gateway in a unique way that will transform the human condition here on Earth, and we want that to be available to you. The goal is to enable everybody to do more. The gateway is that enabler. Now, it's not just an enabler for commercial and international partners. Here's the key. It's also an enabler for science. Historically at NASA, we have had this challenge where every dollar spent on human exploration and operations is a dollar that is not spent on science. And every dollar spent on science is a dollar that is not spent on human exploration and operations. Well, when we go to the moon with the gateway, and we have a communication architecture in orbit around the moon with our commercial and international partners, all of a sudden, the cost of doing things like astrophysics goes way down. Astrophysics is part of the Science Mission Directorate. So it is no longer a zero-sum game. By doing human exploration, we are enabling astrophysics. That's a key enabler. So we got a mission that I'm very excited about. It's being led by the Ames Research Center with other research centers operated by NASA as well. And this particular mission called DAPPER is going to help us see not just back into space or into deep space, but also back into time. We're going to see not just the first light in the universe after the Big Bang, we're going to see before the first light. We're going to see what are called the dark ages. And we can see it from the far side of the moon because it's so quiet from an electromagnetic spectrum perspective. And the reason we're able to think about this now is because we're going to have a communication architecture around the moon that includes the gateway. And that communication architecture means that we don't have to launch a $500 million, a $500 million mission around the moon. We can launch a mission around the moon that does astrophysics for $90 million because there's already an architecture of support there. In other words, we can do more science, not less science, when we do human exploration of the moon. That's a very positive development. And remember, the Viper lander is going to be on the moon as well. And we can have numerous missions to the surface of the moon with humans, some of them American, some of them with our international partners, maybe some of them commercial industry. Maybe they're interested in the platinum group metals that could be on the surface of the moon. People are familiar with rare earth metals. The challenge with the Earth is that we have a very active geology, and a very active hydrosphere, and a very active atmosphere, which means anything that impacted the Earth billions of years ago is not today where it used to be. It's in very trace amounts when you find it at all. Well, the moon is different. It doesn't have an active geology. It doesn't have an active hydrosphere. It doesn't have an active atmosphere, which means anything that impacted the moon billions of years ago is today right where it was billions of years ago, and that would include those asteroid impacts that are those rare earth metals, which in this case would be rare lunar metals. Now, are they there in big deposits? I don't know, and neither does anybody else. But let's go find out. That's what this is all about. Exploration, discovery, and science. Remember the science I talked about just now, how these asteroid impacts from billions of years ago could be today right where they were billions of years ago. But this is also true. The sun has subatomic charged particles coming from it and impacting with the moon all the time because it doesn't have an atmosphere or a magnetosphere. And by the way, those subatomic charged particles are probably today right where they were billions of years ago. So the moon doesn't just represent an opportunity to do astrophysics like the DAPPER mission. It represents an opportunity to do heliophysics, the study of the sun on the surface of the moon. The moon is a repository of the early solar system. So when we talk about the moon, it's about astrophysics, it's about heliophysics, the study of the sun. It's about planetary science. What can we learn about the moon and apply to other planets? And it's about Earth science. A lot of people know or believe, and I don't know, I wasn't there, but a lot of scientists believe that the moon was at one time part of the Earth. And so we can learn maybe about the early Earth by studying the moon. So all of these opportunities are available to us when we go to the moon with human exploration, and all of it enables the Science Mission Directorate of NASA. They are not, in fact, mutually exclusive. They work hand in glove, and all of us can do more when we work together. And that's not just true of the different mission directorates at NASA. It is also true when we bring with us our international and our commercial partners. That's what we're trying to build at the moon. And remember why we're going to the moon. We're learning how to live and work for long periods of time. That's what we're trying to do. Because ultimately when we go to Mars, we're going to have to be there for long periods of time. Earth and Mars are on the same side of the sun once every 26 months. That means when you go, you got to be ready to stay, friends. Some people would suggest we can do a 30 to 90 day stay. Some people suggest you got to be there for 2 years. We're working out the orbital physics. And there's other ways of maybe coming home that are unique, where you can actually do a short duration stay on Mars, where we use Venus as a gravity assist to come home. I'm not saying we're going to do that. I'm saying it's in the realm of what could be possible. But here's what we also know. We need to get to Mars. We need to continue to look and find to see if there is life on another world. The moon is the proving ground. Mars is the destination. We cannot forget why we are going to the moon. Finally, and then I'm going to open it up for some questions. When we went to the moon in the 1960s, we went under a program called Apollo. And in those days, all of our astronauts came from fighter pilot and test pilot backgrounds. And there were no opportunities for women. Well, it just so happens that in Greek mythology, Apollo has a twin sister. Her name is Artemis, and she is the goddess of the moon. This time when we go to the moon, we go under the name Artemis. We're going forward to the moon. This time when we go, we're going to stay. But this time when we go, we also have a very diverse, highly qualified astronaut corps that includes women. This is our generation. We are the Artemis generation. I am the first NASA administrator that was not alive when we had people on the moon. I was born in 1975. Our last mission was in 1972. I don't have that memory. We cannot let another generation go by where we don't have that memory. We need to get to the moon. We need to stay at the moon. We need to learn how to live and work on another world, and we need to go to Mars. This is the Artemis generation. We need to own it. We need to take control of it, and we need to make it happen. Thank you so much for having me. Okay, so I've got questions here on this laptop. Well, there's different questions here. Just so you guys know, what is this thing called? What is it? Slit up. Is that right? So if you guys want to ask questions, here's a way to do it. How far into the Artemis program will NASA deploy in-situ resource utilization experiments on the moon? That's one of the questions. That's the first question. We're going to do it right away. We're hoping to do it in 2021. In fact, we're using the Commercial Lunar Payload Services program, where we're going to the moon with small payloads. We're talking about science payloads, commercially. We're not going to purchase, own, and operate the vehicles. We're going to buy services. Many in this room remember the Google Lunar X Prize. That prize, ultimately nobody won, but a number of companies got formed that we believe have capability of getting us to the moon. And we have turned to those companies and said, can you get us to the moon with a 15 or 20 pound experiment that can help us understand the regolith on the surface of the moon? And the answer was yes. We have now gone under contract with 2 companies that we believe are going to be able to deliver our science instruments to the surface of the moon in the year 2021.